The history of the Southern Lights. Discover the magic of the Southern Lights, a spectacle of lights in the southern night sky, wrapped in mythology and unraveled by science. Explore how exploration and technology have revealed the secrets of this natural wonder. Prepare to be amazed. Chapter 1: The First Testimonies. Since time immemorial, humanity has looked towards the night sky, fascinated by the mysterious plays of light that occasionally adorn the darkness. The Southern Lights, that spectacle of dancing lights in the southern hemisphere, have been no exception. The oldest records of these magical lights are lost in the depths of history, intertwining with the narratives of ancient civilizations and indigenous tales of the lands near our planet's poles. The interpretations of the Southern Lights have varied greatly across cultures and eras. For the indigenous peoples of southern Australia, the lights were manifestations of their ancestors in the sky, a form of spiritual communication that reaffirmed their connection with the universe. Meanwhile, ancient civilizations that recorded these phenomena in texts and paintings often considered them divine omens or auguries of great events, both calamitous and fortunate. This chapter also explores how, despite vast distances and cultural differences, interpretations of the Southern Lights shared a common core of awe and reverence. These celestial lights were considered a bridge between the earthly world and the spiritual, a reminder of human smallness in the face of the cosmos' immensity. Many accounts speak of leaders and wise men who meditated under the aurora's glow, seeking wisdom and guidance. The fascination with the Southern Lights transcends time, serving as a testament to human innate curiosity to understand the universe surrounding us. Through the centuries, this natural wonder has witnessed unimaginable changes, not only in Earth's physical environment but also in the civilizations that have evolved under its light. However, the magic and mystery of the aurora remain, reminding us that there is still much to discover in the vast night skies. Chapter 2: Under the Mantle of Mythology. In the tapestry of global mythology, the Southern Lights hold a special place, woven into the collective imagination of cultures through stories that seek to explain their enigmatic beauty. These mythological narratives, rich in symbolism and meaning, offer a window into how our ancestors attempted to make sense of natural phenomena that defied their understanding. In the cosmology of the indigenous peoples of Tierra del Fuego, for example, the aurora was interpreted as the reflection of gigantic bonfires, lit by ancient spirits in the beyond, signaling the presence and continuity of life after death. These lights were not just a natural phenomenon, but also a spiritual beacon, guiding the souls of the deceased to the next world and offering them comfort and direction. In other traditions, the Southern Lights took on a more belligerent character. Stories were told of celestial warriors who, riding in chariots of fire, crossed the firmament in epic battles that mirrored the earthly struggles of mortals. The aurora, with its vibrant colors and fluid movements, became the stage for these divine confrontations, a spectacle that offered both awe and a warning of the powers that governed human fate. These mythologies, though varied in their details, shared a common purpose: to provide explanations for the mysteries of the cosmos and establish a connection between man and the majesty of the universe. By personifying the aurora as supernatural beings or events, ancient cultures created a sense of order and belonging in a world full of uncertainties. Today, although science has unveiled many of the secrets behind the Southern Lights, the enchantment of these ancient narratives endures. They remind us of the importance of wonder and imagination in our relationship with the natural world, and how, throughout history, the aurora has been a bridge between the earthly and the divine, between science and spirit, between our collective past and shared future. Chapter 3: Early Scientific Theories. As the scientific method began to illuminate the dark corners of human knowledge, the Southern Lights also attracted the attention of thinkers and scientists eager to unravel their mysteries. The leap from mythological interpretations to explanations based on observation and experimentation marked a turning point in the human understanding of this phenomenon. At the dawn of the scientific era, theories about the Southern Lights were as varied as they were fascinating. Some of the earliest scientists speculated that auroras were the result of sunlight reflecting off polar ice or even manifestations of combustible gases in the atmosphere. These hypotheses reflected the effort to apply known physical principles to phenomena not yet understood, in an era where the frontier between the known and unknown was vast and stimulating. Among the pioneers in the study of the aurora were figures like Edmund Halley, better known for his work on comets, who suggested that auroras could be related to the Earth's magnetic field. Although his theories were not entirely accurate according to current knowledge, Halley established a line of inquiry that would prove crucial in the future study of auroras. The 18th century brought with it an exponential growth in scientific interest in the Southern Lights. Expeditions to the polar regions multiplied, equipped with more precise instruments and the goal of recording and understanding this phenomenon. These early scientific forays, though limited by the technology of the time, accumulated a valuable body of observations that laid the groundwork for future research. This period of exploration and speculation illustrates humanity's transition towards a more rational and systematic understanding of the natural world. The insatiable curiosity that led early scientists to question and study the Southern Lights is a testament to the human desire to understand the universe, a legacy that continues to inspire current generations of researchers. Through their study, the aurora ceased to be a mere celestial spectacle and became a gateway to understanding the complex systems that govern our planet and its relationship with the cosmos. Chapter 4. The connection with terrestrial magnetism. The discovery of the relationship between the Southern Lights and the Earth's magnetic field represented one of the most significant advances in understanding this natural phenomenon. It was in the 19th century that scientists began to compile evidence suggesting a direct connection between the manifestations of auroras and terrestrial magnetic activity, a theory that would radically change the course of subsequent research. This crucial chapter in the history of science was marked by the contributions of researchers like Christian Birkeland, whose expeditions to the Arctic allowed him to observe the dynamics of auroras up close. Birkeland proposed that auroras were the result of electrically charged particles emitted by the sun, which, when interacting with the Earth's magnetic field, produced these brilliant light shows. Although his ideas initially faced skepticism, they eventually became the basis for the current model of how auroras are generated. The work of Birkeland and his contemporaries opened the doors to a new era of research, in which plasma physics and the study of terrestrial magnetism gained unprecedented prominence. Innovative experiments were carried out, such as the construction of terrellas, small models of the Earth with magnetic fields, which simulated the conditions under which auroras are produced, offering a visual and practical understanding of the phenomenon. Furthermore, the development of more sophisticated instruments to measure Earth's magnetic variations allowed scientists to establish a more precise correlation between solar activity, space weather, and the appearance of auroras. This understanding enriched the field of geophysics and had practical implications in areas such as space weather forecasting and the protection of technological systems sensitive to magnetic disturbances. The elucidation of the connection between the Southern Lights and terrestrial magnetism marked a milestone in the history of science, demonstrating how curiosity and perseverance can lead to discoveries that illuminate the complexities of the universe. This advance not only deepened our knowledge about the planet we inhabit, but also reminded us of the intimate relationship between Earth and the vast cosmos that surrounds us. Chapter 5. Explorations and Expeditions. The history of the Southern Lights is intrinsically linked to brave explorers and scientists who ventured into the most remote corners of the Earth to study this phenomenon in its natural habitat. These expeditions, fraught with challenges and discoveries, provided a more in-depth understanding of auroras and expanded the limits of human knowledge about the polar regions. In the 19th and 20th centuries, expeditions to Antarctica and the southern zones became emblematic scientific adventures, motivated by the search for answers to natural enigmas and the desire to map the planet's last unexplored territories. Scientists and explorers, equipped with the most advanced measurement instruments of their time, faced extreme conditions to observe auroras and collect data on this spectacular phenomenon. One of the prominent figures in this era of exploration was the Norwegian explorer Roald Amundsen, known for being the first man to reach the South Pole. Amundsen, on his journey to the pole, made detailed observations of the southern lights, contributing significantly to the study of the phenomenon. The notes and measurements taken during these expeditions were fundamental in advancing the understanding of the relationship between auroras and Earth's climatic and magnetic conditions. These journeys were not only aimed at studying the aurora, they also provided crucial information on meteorology, glaciology, and polar geography. The spirit of these expeditions highlights the intrinsic human curiosity and thirst for exploring the unknown, characteristics that have driven scientific progress throughout history. The legacy of these expeditions is invaluable. The data collected during these pioneering journeys continues to be an important reference for current scientists. Furthermore, the stories of courage, perseverance, and discovery continue to inspire new generations of explorers and researchers, reminding us that, despite technological advances, the spirit of exploration is essential for unraveling the mysteries of the universe. Chapter 6: Technological Advances in Observation. The study of the southern lights has been revolutionized by technological advances, especially in the areas of photography, telemetry, and satellite technology. These tools have allowed scientists and enthusiasts to capture and analyze the phenomenon with unprecedented precision and detail, opening new avenues of research and understanding of this natural spectacle. The introduction of photography in the study of auroras, at the end of the 19th and beginning of the 20th centuries, marked a before and after in the ability to document accurately the variability and beauty of these lights. Cameras, increasingly sensitive to light, allowed not only to capture stunning images but also to record the movements and changes of auroras over time, offering an invaluable tool for their detailed study. The advent of the space age and the development of telemetry and satellite technology have taken the observation of the southern lights to a new dimension. Satellites equipped with specialized instruments for observing space weather have provided a unique perspective on auroras, allowing them to be studied from space and understood interacting with Earth's magnetic field and solar wind. These advances have been crucial in developing more accurate models of how auroras are generated and how they vary in response to solar activity. Moreover, technology has democratized access to aurora observation. High-sensitivity cameras and drones with high-definition recording capabilities have allowed amateurs to capture spectacular images of auroras, contributing to citizen science and fostering a broader interest in this phenomenon. Social media and digital platforms have facilitated the dissemination of these images and observations, creating a global community of aurora enthusiasts. These technological advances have not only enriched our scientific knowledge of auroras but have also transformed the way we experience and appreciate this natural phenomenon. The ability to document and share the beauty of the southern lights with a global audience has reinforced its place as one of the planet's most fascinating natural wonders, driving both scientific research and public appreciation for this spectacular celestial event. Chapter 7: The Physics of the Aurora. The understanding of the southern lights has advanced significantly with the development of plasma physics and space research, revealing the complex processes that give rise to this natural phenomenon. By unraveling the physics behind the aurora, scientists have managed to explain how the interaction between the solar wind, Earth's magnetic field, and the planet's atmosphere produces these impressive displays of light. The solar wind, a stream of charged particles emitted by the sun, travels through interplanetary space until it encounters Earth's magnetic field, the magnetosphere. This encounter triggers a series of complex interactions, where charged particles are channeled towards the Earth's magnetic poles through magnetic field lines. As they approach the Earth's atmosphere, these energetic particles collide with atoms and molecules of gases like oxygen and nitrogen, exciting them to higher energy states. As these atoms and molecules return to their original energy state, they emit photons, creating the bright lights characteristic of auroras. The colors and patterns of the aurora depend on several factors, including the type of particles that collide, the altitude of these collisions, and the atmosphere's density at those altitudes. For example, collisions with oxygen at high altitudes tend to produce green and reddish lights, while interactions with nitrogen can generate blue and purple tones. Research in this field has been driven by satellites equipped with specialized instruments, which allow measuring the interactions between the solar wind and Earth's magnetic field directly in space. These data have been fundamental in validating theories and models about how auroras are generated, offering a more precise understanding of their behavior and variability. The physics of the aurora is not only a fascinating research topic in itself, but also provides valuable insights into other astronomical and planetary phenomena, such as solar storms and their impact on Earth's space environment. This knowledge is crucial for predicting and mitigating the effects of solar activity on technology and communications on Earth, underscoring the importance of auroral science in our technologically advanced society. Chapter 8: Impact on Technology and Communications. The Southern Lights, along with their northern counterpart, the Aurora Borealis, are more than visually impressive phenomena. They have significant implications for modern technology and communications. These effects are the direct result of the geomagnetic storms that accompany auroras, which can disrupt the functioning of satellites, power grids, and communication systems, presenting unique challenges to our technological infrastructure. Geomagnetic storms are caused by intense variations in Earth's magnetic field, provoked by the arrival of strong streams of solar particles. When these particles interact with the magnetosphere and ionosphere, they can induce electric currents in the upper atmosphere and on the Earth's surface. In the case of power grids, these geomagnetically induced currents can cause overvoltages and failures in energy transmission systems, which have occasionally led to extensive blackouts. In the realm of communication, auroras can affect radio signals, especially at high and low latitudes, disrupting short and long-distance radio communications. This effect is due to disturbances in the ionosphere, a layer of Earth's atmosphere that reflects radio waves, which are affected during intense aurora events. Moreover, the operation of satellites, crucial for GPS navigation, telecommunications, and Earth observation, can be compromised by these solar storms, affecting everything from GPS accuracy to the integrity of transmitted data. Faced with these challenges, scientists and engineers have developed a series of strategies to mitigate the negative impacts of auroras on our technologies. This includes designing more resistant satellites and power grids to geomagnetic fluctuations, as well as early warning and monitoring systems that can predict solar storm events, allowing operators to take preventive measures to protect critical infrastructure. Ongoing research in this field not only seeks to better understand how auroras interact with our technological environment, but also to develop innovative solutions to ensure the resilience of our societies in the face of dynamic solar activity. Thus, the study of auroras stands at the intersection between pure science and practical application, demonstrating how the most sublime natural phenomena can have tangible effects on our daily lives and technological advancement. Chapter 9: Current and Future Research. The field of research on the Southern Lights is constantly evolving, driven by technological advances, international collaborations, and a more profound understanding of our solar system. Current projects range from the detailed study of the interaction between solar wind and Earth's magnetic field to exploring the effects of auroras on space weather and their impact on human technology. One of the most promising areas of research involves the use of networks of satellites equipped with advanced sensors to monitor in real time the variations in Earth's magnetosphere and ionosphere. These projects, like the European Space Agency's SWARM mission, are designed to collect precise data on electric currents, magnetic fields, and charged particles in the space around Earth. This information is crucial for improving our understanding of how solar storms give rise to auroras and how these phenomena affect our space environment. International collaborations also play a fundamental role in auroral research. Projects like Super Dual Auroral Radar Network, a network of high-frequency radars spread around the world, allow scientists to study the dynamics of the upper atmosphere and ionosphere on a global scale. These initiatives combine resources and expertise from various countries and organizations, underscoring the global nature of auroral science and its relevance to all of Earth's inhabitants. Moreover, research stations in Antarctica play a crucial role in studying the southern lights. The unique location of these observatories allows researchers to observe auroras under ideal conditions, free from the light pollution present at lower latitudes. The data collected at these stations contributes significantly to our predictive models of auroral activity and space weather. Looking towards the future, research on the southern lights will focus on leveraging new observation and data analysis technologies, such as artificial intelligence and machine learning, to decipher the complex processes underlying this phenomenon. Additionally, increasing international collaboration and the development of new research infrastructures in remote spaces are expected to open new frontiers in our understanding of auroras and their impact on our planet and beyond. Thus, research on the southern lights not only seeks to satisfy our scientific curiosity, but also to better prepare us for living in a world increasingly affected by space weather. Through the study of this fascinating natural phenomenon, we can expect not only to advance our knowledge of the universe, but also to improve the safety and efficiency of our technologies and societies. Chapter 10: The Visual Spectacle Today. The Southern Lights, with their dance of lights at night sky, continue to be one of the most astonishing and accessible natural spectacles for people worldwide. As we move forward into the 21st century, the appreciation and experience of this phenomenon have been transformed and enriched by technology and digital media, bringing the beauty of the aurora closer to those who do not have the opportunity to observe it in person. Popular destinations for observing the southern lights, such as Tasmania, New Zealand, and Patagonia in Chile and Argentina, have seen an increase in astronomical tourism. Travelers from around the world are drawn by the promise of witnessing this phenomenon, which has spurred the development of services and activities focused on aurora observation, from specialized tours to accommodations with transparent domes for uninterrupted celestial viewing. Furthermore, aurora photography has undergone a revolution thanks to the availability of high-sensitivity digital cameras and long-exposure techniques. Photographers, both professional and amateur, can capture images of auroras with a level of detail and color previously unattainable. These images not only serve as a testament to the phenomenon but also play a crucial role in scientific dissemination and inspiring a sense of wonder and curiosity about the natural world. Social media and digital content platforms have facilitated the spread of these stunning photographs and videos, allowing people from all over the world to experience the magic of the southern lights from their homes. This democratized access has fostered a global community of aurora enthusiasts, sharing tips, stories, and, most importantly, a collective admiration for this natural spectacle. The southern lights, therefore, are not just a scientific phenomenon of interest to researchers but also a source of inspiration and awe for humanity. Their presence in popular culture and digital media has reinforced their status as one of our planet's most fascinating natural wonders. As we continue to explore and understand this phenomenon, The aurora reminds us of the inherent beauty of the world we live in and the importance of protecting these natural spectacles for future generations.